A very good evening to a very good evening to all of you. So today I am going to talk about the architecture that we have implemented at Uran. Here on the left hand side you can see two level 1 and 2. It talks about the data historian and the system 1. DCS will pick the data from the historian will pick the data from the DCS, and that DCS will be having the data from the process side. Process side data includes uh, seal oil parameters, lube oil parameters, first stage suction pressure, discharge pressure, flow across the intermediate pressure, intermediate process. It is being present in the DCS, and the system 1 is having the machine data which is related to the gearbox, motor side and compressor side vibrations and temperature. The data is stored in the level 2. That data is being captured into the level 3, and level 3 comprises of CRTDMS, that is Central Real Time Database Management System. That system is also capable of transferring the data to the PM solution, which is nothing but your PM server. That CRTDMS is having the provision of manual data, such as if there is any inspector visit or field operator visit. It can show if there are any visible issues such as leakages or cracks, that can also be manually entered. Business events related to the downtime or startup if something is being planned. Spectrum analyzer data if available in any standard format. Lab data such as oil quality data. Benchmarking data, which is basically nothing but your design data, performance curves, and the OEM recommendations if any. The whole data is being transferred into the CRTDMS, and the data PM solution is having the capability to visualize this whole thing. What it will basically does is it will capture this data, and processing of this data will take place, and some internal calculations will be done, based on which a model will be prepared. It will be a statistical model. That model will be having a capability to tell about the physical damages, to tell about the physical assets, how it would be, how the actual machine will work in similar to that the physical machine. And on top of it, a series of visualization layer is also being implemented for, and that will give a dashboard which will be available to the stakeholders. And further, there can be a provision for capturing the data to the SAP module or ERP module for conducting any maintenance updates or maintenance orders. So this is about the Uran predictive maintenance solution, typical architecture that we have published in the tender. There is also provision of keeping the IIoT sensors in the system. Now this is how a digital predictive solution works in general. When we talk about which is a machine learning based system, basically there are 5 steps. First one is what are all the key parameters that we are supposed to capture, and what are all the relevant data sources which are available. Second step is to acquire that data into a meaningful sense so that it makes sense to the model. It has to be kept in a structured way. And the third step is the data processing and the model redeployment. After capturing the data, if there are some missing values, or if there are certain anomalies, or say a sensor is missing, it can be deployed, and the cleaning of the data also takes place. It is about removing the noise from the data, removing outliers, and based on which this process data, lab data, real-time data, SAP data, and design data, a model is being developed. That model is an artificial intelligence, a neural network based model, or it can be any machine learning model. That model is having the capability to tell about what are all the various failure modes and how good it can work in under different circumstances, based on which the historical data, the model is being trained. Once the training is being carried out, the model keeps on learning on its own, and it will be in a very good position to tell at a certain point of time if there are any breaches in the threshold, or say like if there are certain challenges which is being associated. Also, confusion matrix or error matrix is being formed. This matrix can give you a meaningful insight. Now the next step is the visualization layer. This visualization layer is capable of telling the raw data from the field, from the various sources which are available. It can also give the real-time alerts for what are all the critical parameters and the things which I have to look upon. It can also tell about what are all the bad factors or which machines needs your attention on immediate basis. Or the model is also capable of telling about if there are any anomalies detection, so that a quick action can be taken place. It can be very visually attractive in the sense it can tell like suppose there is a failure, like then based on which it can tell how good is it to implement. It can tell what are all the failure severities with respect to the 3 failure modes. It can be expanded. The model will learn over the period of time and will give a very quick overview of how the machine is behaving over the period of time. The interesting things about the machine learning model is that the learning from one model can be transferred to the another model, and there is interoperability of the learning, and with the period of time the model grows itself, the model learns itself. I think you would be able to appreciate the chat gpt came somewhat between December 2023. If somebody has used the chat gpt back then they might be able to appreciate now how good the chat gpt present is. So this is how the machine learning works. Once your model is trained on a large set of data, then the model can predict your impending failure and your remaining useful life also in a much better way. So this is the case study. This is what we have done in Uran. We have selected 8 compressors of different makes and models and different service conditions also, like centrifugal machines, reciprocating machines, screw compressors, expander compressors. And idea behind selecting these machines was that the data was also available in an electronic form so that it can be fed into the model directly. And the subscription model was OPEX as suggested by the consultant Accenture. What are all the key highlights of the predictive maintenance? So generally it is an AI and machine learning based software solution. The idea is to develop predictive analytics solution for critical equipment. There is a possibility of real-time data handling, alarms and notification to make you alert in advance, role-based dashboards for the different key stakeholders to visualize data trends, early warning signals, and residual life prediction is also one of the key parameters. It can also tell you what has gone bad and what was the root cause for a failure based upon the learning of the model. And definitely you can do a training, and change management can also be implemented in this. Now, to give you a larger picture how the industry is seeing this predictive maintenance, let's take an example of ADNOC. What ADNOC has done in the 2019 as a part of their digital initiative, in which the key line was every oil counts. Basically, what they suggested that to make every oil a valuable, it they have used a digital turnaround, and they have hired Honeywell to run their solution, and it has been implemented for like more than 25 assets has been covered in that particular thing. And they were like in a position, and they forecasted that yearly they would be able to solve 20 to 25 millions from that project, and 1.5 million dollars savings after implementing digital twins. And they were also designing their digital panorama platform, and they have implemented in their upstream downstream assets and process management and to help it. So this is how also we can extend. They expect the annual productivity to be increased by $3 million. Thank you.